Question 22 from the 2024 Higher Physics Examination of the SQA Section 1. A circuit is set up as shown. We have a 12 volt battery, a switch, an ammeter, a resistor and a capacitor. The capacitor is initially uncharged, switch S is now closed and the capacitor begins to charge. The graph shows how the charging current I in a circuit varies with time, and you can see we have the graph there, the famous graph. As you charge the capacitor up, we have initially a high current flowing, and then as the current reduces down to zero, we know the capacitor is fully charged. We know also that the maximum currents which will be flowing in a circuit depends just on the value of resistance and the voltage of the supply. Now, it says the capacitor is now replaced with an uncharged capacitor of greater capacitance. The same charging process repeated with this capacitor. And we're going to pick which graph we're going to have when we charge up the circuit again. Now, we haven't changed the value of the resistance and we haven't changed the value of the voltage, and we know that the maximum current flowing is going to be just simply V over R. So when we replace the capacitor here with a new capacitor, then it's not going to affect the maximum current flowing. So we're looking for a graph which is still going to have a maximum current of 30 milliamps. It's definitely not going to be that one. It's definitely not going to be that one. It could be this one. And it could be this one, and it's definitely not that one. So what's the deciding factor? Well, if we have a larger capacitor, it's just like talking about a glass. If we fill a glass of water from the sink and we replace with a bigger glass, it's going to take longer to charge up. So what we're looking for is the same maximum voltage, but a longer charge time. And it's this one here, because it's going to take longer to charge up. This one here is going to take the same amount of time. This one is going to take longer. So the answer to that question is 22C. Now, I can show you a simulation of that from a very good app called Everyday Circuit, or Every Circuit. I'll give a link to it in the show notes, and that will show you how the capacitor charges if you vary the capacitance. That's coming up next. Here's a simulation of the circuit which appears in the exam paper to the best this simulation can do. It looks complicated, but it's not really. We have got a 12 volt battery as we have in the exam paper, a switch, an ammeter and a resistor and a capacitor. We have a switch to turn on the circuit, which means the capacitor will charge. Don't worry about this part here, that's just really a little simple circuit attached to the capacitor which allows it to be discharged, so we can replace the capacitor with a bigger value and have the capacitor uncharged. Now this part up here is going to show you the graph of the current. So I'm going to run the circuit and I'm going to press this the switch to start off, and there you go, you can see the classic case of a capacitor charging up circuit. I'll just stop it there. You can see you have got a maximum current flowing, I think about 30 milliamps, and the current decreases and decreases down until it gets this value here of 0. That means it's fully charged. So I want you to take a look at that graph and remember it. You've got a 30 milliamps maximum current and the graph sweeps down like this. And now what I'm going to do is change the value of the capacitor. Now I've got a capacitor of 70 microfarads, a much bigger capacitor, and I'm going to release the switch. And you can see we've got the same value of the current, but look what happens to the graph. It's much more stretched out. It's taking a longer time to become fully charged. Same current flowing, because really the maximum current flowing only depends on the resistor and the voltage supply. We haven't changed that, so the maximum current is going to remain the same. But look what happens to the time it takes for the circuit to completely charge. It's taking longer because we've got a bigger capacitor, and think of a capacitor as a glass which to fill with water. If you fill the glass with water and then replace that glass with a bigger glass, it's going to take longer to fill. So that's why we get the graph that we've chosen. The maximum current stays the same, but the time for charging is a lot longer. Question 23 from the 2024 Higher Physics exam from the SQA Section 1. Solids can be categorised as conductors, insulators or semiconductors. The diagrams show the valence band and the conduction bands for 3 solids, X, Y and Z. Which row in the table shows the letters that represent a conductor, an insulator and a semiconductor. Well, the clue is look first of all for the conduction band and the valence band being so close together, almost overlapping one another, and that is the conductor, and that's going to be solid X. So solid X is the conductor. Then you go to the opposite extreme and look for the band gap to be as wide as possible. That will be the insulator. The band gap between the conduction band and the valence band being very big, that's the insulator, and that's going to be solid Z. So that's going to be an insulator for this one, insulator. And of course this one here is the semiconductor, because the band gap between the conduction band and the valence band is not as big as a insulator, but it's also, you can see there's a gap there, so that one will be in fact the semiconductor. Okay, so we're looking for a conductor for X, which means it's either that one or that one, and we have a semiconductor for Y, so obviously that's wrong. So we've got semiconductor is Z, insulator is Z, and the semiconductor is Y. So the answer to this one is going to be D. X is the conductor, Z is the insulator, and Y is the semiconductor. Question 24 from the 2024 Higher Physics exam from the SQA, taken from paper 1, the multiple choice. An increase in the temperature of a semiconductor increases its conductivity by allowing more electrons to reach the conduction band. Statement B increases its conductivity by increasing the band gap between the valence band and the conduction band. Statement C decreases its conductivity by allowing more electrons to reach the conduction band. And part D decreases its conductivity by allowing fewer electrons to reach the conduction band. And E has no effect on its conductivity. Let's take a look at this little movie here of a conduction band, valence band, and a semiconductor. You can see the conduction band and the valence band are not widely separated. They've got a small enough energy gap which heat added to it will promote some of the electrons up. And you can see adding heat promotes some of the electrons up and leaves a little bit holes behind. So what's happening here? Then a little bit of heat in a semiconductor does increase its conductivity because more electrons are allowed to reach the conduction band. You can see these electrons in the empty conduction band of the semiconductor, and of course that means it's going to be a better conductor. So when we look for all those statements, we're really looking for an increase in conductivity by allowing more electrons to reach the conduction band, and that is statement A. Increasing the conductivity by increasing the band gap. No, the band gap does not increase, it stays the same. Statement C decreases its conductivity by allowing more electrons to reach the conduction band. No, you could have a decrease in conductivity rather than an increase in conductivity. And statement D, decrease in conductivity, once again we ignore that one. It's got to be an increase in conductivity with an increase in the temperature of the semiconductor. That's all because when you heat it up, some of the electrons in the valence band have enough energy given by the heat to jump the energy gap and get into the conduction band. So answer 24A. Question 25, the last question of the 2024 multiple choice paper in higher physics from the SQA. A student connects 4 identical red light emitting diodes, LEDs, to a 2-volt RMS AC supply as shown. That's the circuit there. And we're asked to find which of the LEDs P, Q and R and S will emit light. Well, we know an AC supply, one half of the cycle we have a plus at one side, and the other side we have a minus. And you can see this LED here is wrongly connected because the negative part of it is connected to the positive part, so that one will not light. This one here is connected properly. The negative part here of the LED is connected to the negative part here, and the positive part on this cycle is connected to the proper part here going through the triangle, so this one will light. Now it's this one here, positive part is connected to the negative part of the LED, so it's not going to light, and because it's not going to light, it will block any electricity going through this one, so really effectively R and S will be off on that half cycle. So we've only got Q lighting up there. Now what happens when we exchange in the next part of the cycle where the AC supply goes minus and plus? So we'll put that in, minus and plus. And you can see the plus side is connected to the correct configuration of this LED, therefore that one's going to light. This one here, the plus part, is connected to the negative part of the LED, so it's not going to light this one here. And the same story applies to this one. The plus part is connected to the bar of it, which really blocks any more electricity from going through here. So P is going to light. So in this particular diagram, in this connection, it's only going to be LEDs P and Q that are going to light. And we can see this in this simulation here. You can see that every half cycle, one red light is lighting, the other one's going to light in the next cycle. But notice the two bottom LEDs are not going to light, because on each of the cycles, one of those LEDs is going to block the electricity from going through that branch. So the answer to this last question of the multiple choice is we're only going to have LED P and LED Q only is going to light in this particular setup. The answer is going to be C, P and Q only. And you can watch the little movie.